Hello viewers, welcome to Cloud Mastery channel. Here we're trying to unleash the potential of cloud computing. This is recently created channel. I want to create videos on different GCP services, especially cloud computing. In cloud computing, I want to concentrate firstly on GCP. So in GCP, I will take each service and will try to create series of video on each service so that it will be helpful for the learners out there. So let's get started with cloud storage. So we're going to discuss on these components within Google Cloud Storage. We're trying to understand what Google Cloud Storage is, like an introduction, and we will see the different ways to interact with cloud storage. And we have some naming standards to the buckets. So we will see like what are the so first we will see what is bucket and what are the different naming standards to the bucket, and the bucket locations. And we have a very important concept in GCS, which is storage classes. We will see on a high level what are the different storage classes are and how they are useful. And then there is a new concept recently introduced by Google, which is auto class. So we will also discuss about auto class. We will discuss more about what public access prevention is and what access control model is, data encryption options, and finally we will see a live demo. So these are the different list of items that we are going to discuss. So let us try understand what cloud storage is. Cloud storage is basically which is useful for you to store objects within a container called a bucket. So in Amazon we have Amazon S3. So in Amazon S3 also we have a bucket concept, so in which we can store objects within the S3 bucket. So in the same way we can have we can create buckets within the cloud storage, and then we can store the objects within cloud storage. And those objects which are being stored in the cloud storage are immutable, meaning that you cannot change the contents of the cloud storage bucket once you upload it into it. In case if you have to change them, you have to download it to your local and then change, and then you have to again upload it. So let us see the different ways we can interact with cloud storage bucket. So there are so it's not only for cloud storage, for any service within GCP. These are the ways we can interact with those GCP services. So the first and foremost is GCP console. In case if you need to create a cloud storage bucket, you can do that by using cloud console. So you can just go to cloud storage and then click on create bucket, and then you can directly create the buckets using console itself. So in the live demo we're going to create the bucket using console itself. So you will get to know how we can create a storage bucket using console. And we can also create or interact with cloud storage using client libraries. So these client libraries are available in different programming languages like Java, Python, Node.js, etc. So you can use the client libraries of any of these programming languages, and then you can interact with cloud storage buckets. And the next one is REST APIs. So we have JSON based and XML based APIs which can manage your data. So you can interact to cloud storage using these REST APIs as well. And the final way of interacting is command line interface. Command line interface is basically using GSUtil commands you can interact with Google Cloud Storage. So you need to have Cloud SDK installed in your machine as a prerequisite for this. So once you have the Cloud SDK installed, you can run GSUtil commands to interact with cloud storage. So we also have gcloud commands, bq commands to interact with other services. So these are the different 4 ways using which you can interact with cloud storage bucket. Now we will see what are the different naming standards to create a cloud storage bucket. So these are the different naming standards. So basically you can only have lowercase letters, numeric characters, dashes and underscores, as well as dots in your bucket name. So with dot there is a specific case, so whenever you have dot in your cloud storage bucket, it identifies that as a domain. So you need to have verify that domain in order to create a storage bucket using dot. And you cannot have spaces in between the bucket name, and the length of a bucket name can be starting with 3 characters till 63 characters. So your bucket names cannot be represented as IP addresses basically. And you cannot have a name like Google within your cloud storage bucket. So these are the different naming standards while you create a cloud storage bucket. So we will understand the different bucket name considerations. The cloud storage bucket is globally unique, meaning that you cannot have one cloud storage bucket name which already exists, not only within your project, but globally across any GCP project basically. So it's basically globally unique. So you cannot have duplicate names for cloud storage bucket. And bucket names are publicly visible. So in case if you have a bucket in a project X, and if you are working in project Y, you can access the contents of project X in your project Y, provided there are IAM permissions given to you. So in a way that these buckets are globally visible across different GCP projects. So you cannot keep PA information in your cloud storage buckets. And once you delete a bucket, anyone can reuse the same bucket name. So you cannot reserve your bucket name. You can use a bucket name in a DNS record, meaning that you have, in case if you have created a bucket like a DNS bucket, and you can use that bucket name within a DNS record. So as part of CNAME is basically a canonical name. So as part of canonical name, you can use the bucket name, DNS bucket name. So there is a different concept, DNS buckets. So I will create a different video on how we can create a DNS bucket within GCS. So here we have some examples of valid bucket names and invalid bucket names. So for instance, if you see my cloud mastery is the bucket name, which is valid because all in lower cases. And if you see in right hand side, you have some capital letters in my cloud mastery, so that is invalid bucket name. And you also see Google keyword within a second invalid bucket name, so this is also invalid. And if you see the third one within a valid bucket name, it's basically a domain kind of name, so test.example.com. so the example.com needs to be verified for the ownership, so it needs to be a proper domain, example.com, then the bucket name will be valid. So now let's talk about bucket locations. Let us try and understand about bucket locations. We have 3 type of locations, like regional, dual regional and multi-regional. Regional storage buckets are basically so you might have know the concept of regions and zones. Region is basically a geographical location, like you have Europe West 3, Europe West 2. So Europe West 3 is for Frankfurt, Europe West 2 is for London, Europe West 1 for Belgium. So these are the different regions, so different geographical locations, these are called regions. So so one region is basically has 2 or more zones. So each zone is like, in case if it is Europe West 3, the zone within Europe West 3 is like Europe West 3A, Europe West 3B. So these are the different zones. So these are the physical data center locations. So this is how the regions and zones are defined within GCP. So regional storage buckets, in the sense the data that you created, so the storage bucket that you defined as a regional storage bucket, then the data is redundant across different zones in the same region. So for example, you have created a storage bucket in Europe West 3 Frankfurt, then the data within the storage bucket is redundant across different zones. within the Europe S3. So like the same data will be replicated in Europe S3A and Europe S3B for the high availability. So this is the regional bucket. So the data will be redundant across different zones in the same region. Whereas dual region is specific to the pair of regions. So it can be the data will be replicated across different regions, different zones in the two regions basically. So for example, if you create a dual region bucket between Belgium and Frankfurt, and the data will be redundant across different zones in these two regions. So that's how the dual region concept works. And one other important thing is the dual region buckets are geo-redundant. Objects that are geo-redundant are stored redundantly at least two separate geographical places separated by at least 100 miles. So that's the concept of geo-redundance. Finally, the multi-region. Multi-region is a large geographical area, such as like United States is one geographical area, as Asia is another geographical area. So the data will be redundant across different regions of different geographical areas. So objects in a multi-regional buckets are geo-redundant. So let's try understand about storage classes now. Storage class is basically a piece of metadata that is shared by all objects in the bucket. So the storage class that is assigned to an object affects its availability and pricing model. So when you create a bucket, you can choose the bucket's default storage class. So when you add an object to a bucket, they inherit the storage class unless you explicitly set a different storage class. So by default, it is standard storage class. We have four storage classes: standard storage class, nearline storage class, cold line storage class, and archival storage class. Standard storage class. So standard storage class is best when you have the recent frequently accessed data. So when you want to create a storage bucket and you want to frequently access that data, then you better keep that data in a standard storage class. The benefit of standard storage class is it is highly available. So we have different SLAs defined for the standard storage class. So if it is multi-regional, availability is 99.95%, and monthly availability is greater than 99.99%. If it is dual region, availability is 99.95%, and total monthly availability is greater than 99.99%. And if it is regional, it's like 99.9%, and typical monthly availability is 99.99%. So this is how it is highly available. So standard storage class is highly available. And the next one is nearline storage class. So nearline storage class is a bit low in cost comparatively with standard storage class, and it is highly durable storage service for storing infrequently accessed data. So nearline storage class is a better choice than standard storage class in scenarios where slightly lower availability. So it's like in case if you need to access the data at least once in a 30 days. So in such cases, you better use nearline storage class. So nearline storage class is ideal for the data that you plan to read or modify on an average once per month or less. So the SLA is also like 99.9% availability in multi and dual region, and in regional it's 99.0% availability, and typical monthly availability is around 99.95%. The next one is cold line storage class. So cold line storage class is very low cost, highly durable storage service. It's lower cost than nearline storage class. So cold line storage class is better choice than standard and nearline storage class in scenarios where you have slightly lower availability, and at least if you access the data once in a quarter. So in case if you modify or access your data once in a quarter, once in a 90 days, you better go with cold line storage class. So cold line storage class is also have an availability of 99.9% in multi-regional and dual region, and regional it is 99.0% available as SLA, and typical monthly availability is 99.94% for multi-regional and dual regional, and it is 99.9% in regional storage class. So next one is archival storage class. Archival storage class is lower cost and highly durable service for data archiving, online backup, and disaster recovery. In case if you have to store your data in a backup, so if you want to keep the data in a backup and you're not frequently accessing, then you better use archival storage class. The name itself suggests it's an archive. So in case if you want to archive something, archive storage class is best suited for it. So like nearline and cold line, archive has slightly lower availability than standard storage class. So it's basically for multi-regional and dual regional, it's 99.9% available, and for regional it is 99.0% available. And typical monthly availability is 99.95% for multi-regional and dual regional, and 99.9% for regional storage class. Okay, so these are the different storage classes we have in Google Cloud Storage. So another thing is we also have a concept of auto class. So auto class is basically it's based on an access pattern of each item within your cloud storage bucket. So what auto class does is automatically transfers your object to appropriate storage class based on their access patterns. So so they call it as hot data and cold data. Hot data in the sense if any object within your cloud storage bucket is frequently being accessed, then that object is called hot data. So what it basically does, it automatically converts storage class for that object to standard. And in case if the data is cold, meaning that this is not some objects in a cloud storage bucket which are not frequently accessed, then that is a cold data. So that cold data is kept under nearline or cold line storage class. So this transition will happen automatically based on the access pattern. So this is basically recently introduced concept. I did not see that before. So this is, I think, very useful feature which is given by Google. So this will be useful when you do not have any information about how frequently we access the data that we store in a cloud storage bucket. So this is an important feature. So it's better you keep auto class for the storage buckets if you do not know before whether it will be accessed frequently or infrequently. So that's about auto class. Let's try understand about public access prevention. Public access prevention is basically protects cloud storage buckets and objects from being accidentally exposed to the public. So there are certain cases where the developers or the cloud engineers will by mistake make some of the very restricted and very secure or sensitive data within your cloud storage bucket. Cloud engineer may accidentally keep that bucket as public, give some IAM permissions to that bucket so that it can be accessed by anyone in the public internet. So in the same way, he might have created some ACLs, access control list, on any specific cloud storage object, which leads to that object being publicly exposed to in the public internet. So in order to prevent such cases, in order to prevent this kind of accidentally exposing the storage bucket to the public internet, they created a feature, basically public access prevention. So we can just use this, there's a check mark, basically if you just check this, then that specific storage bucket data will not be able to will not be able to publicly exposed. Though in case if by mistake we give some ACLs or some IAM policies to expose that bucket to the public internet, this public access prevention will not let you expose this data to the public internet. So that's how this public access prevention works. Let us talk about access control model. So access control model is basically when you create a bucket, you should decide whether you want to apply permissions using uniform or fine-grained access. So these are two different types. So uniform in the sense Uniform bucket level access allows you to use IAM alone to manage your permissions. So you cannot use ACLs. So which means you cannot manage permissions to the individual objects within your storage bucket. So it is whatever IAM permissions that you specify, it will be at a bucket level, not at individual object level. Whereas fine-grained access control is basically which enables you to use both IAM as well as ACLs to manage your permissions. So ACLs are legacy access control systems. So you can specify access and apply permissions at both bucket level, also at an individual object level. So this is fine-grained access. So uniform is mostly recommended because you have more control over the buckets, more control over the objects within your storage bucket. Now let's talk about data encryption. So in data encryption, so when we talk about data encryption, cloud storage always encrypts your data on the server side before it returns to a disk. So it always encrypts your data at no additional charge. So this is a default Google Cloud Storage behavior, and there are also additional ways to encrypt your data using cloud storage. So there are two ways that you can do the encryption. So one is server side, another one is client side. So when you say server side, encryption which will happen after cloud storage receives your data, but before the data return to the disk and which is being stored. So before it stores the data, before it writes the data to a disk, it encrypts it. So that's called server side encryption. Whereas client side encryption is encryption that occurs before data is sent to cloud storage. So at the client side itself, it encrypts your data, and such data arrives at cloud storage already encrypted, but it also undergoes server side encryption. So this is the difference between server side and client side encryption. So in server side encryption, there are two options given by Google. So one is customer managed encryption keys you can use, and customer supplied encryption keys you can use. So when you use customer managed encryption keys will be created by cloud management service itself, which is given by GCP, Google. So you can use cloud management service to create the customer managed encryption keys. So it's basically Google service. So you're using Google service to create your keys, and customer will manage those keys. Google will not manage. So that's basically customer managed encryption keys. And customer supplied encryption keys, you can create and manage your own encryption keys. So you do not use cloud key management service to create your keys. So you use your own algorithm, your own method of creation of encryption key, and you use that encryption key for you supply that encryption key while you create a cloud storage bucket. So this is basically data encryption. I hope you like the video. Thank you. If you like the video, please share, subscribe. Thank you.